Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, we have come to the last topic of the project management, that's using PERT. So, what is PERT? It's a project evaluation and review techniques. If you see its history, it was developed by the US Navy for the planning and control of Polaris missile program in 1957. We have already discussed that. So, what the motto was to complete the program in a shortest possible time. The most important thing in the PERT is that we have uncertainty. The activity completion time, we are very uncertain about the completion time. We don't know exactly. We have no previous experience. Okay. In your CPM, you had a previous experience. You could actually tell what is the exact project completion time. But here we have what is called the uncertainty. Now, the program evaluation review technique, or we say project evaluation review technique, it is a management tool. I use it to schedule, organize, and coordinate tasks within a project. We actually facilitate here decision making. Basically, the optimization is all about decision making, right? And we want to optimize in terms of time and cost. We want to reduce both time and cost required to complete a project. In CPM, we had a deterministic approach because we know the exact time, but here we don't know, so that's why it's a probabilistic approach. And it is used while you do not have any past experience. So that's why it's probabilistic, because we don't know exactly what the time is. We have not done, if we have done some project already and we want to do it, redo it, then we already know what is the time it's going to take. But if we don't know, then the PERT is going to help us. So the steps involved are, we first, like the CPM, identify the specific activity and their milestones and what timings they have. They will be probabilistic times, not the exact times. Okay. Then we need to determine the proper sequence of activities. Okay. Then after that, we can construct a diagram if we know the activities and what are the sequences they have, which activity comes after which activity. If we know that, we can construct a network diagram. Then we estimate the time required because we have the probabilistic time here. So we will calculate the estimated time, okay, for each activity using the formula. We will see that. Then after that, we'll determine the critical path and we update the PERT chart as project progresses, right? Now, where is the PERT used? What is the field of application? If you have a large scale, one time, non-routine means we have not done it before. It is just a one time, we are just doing it right now, for example, and very complex projects with a high degree of inter-task dependencies. And there's inter-task dependencies, right? So a project which requires a series of activities, which we can done sequentially, one after other, or we can do it in a parallel. You can do this way, this also, you can do this also simultaneously. And there is a risk of time associated with the project because we don't know exactly what the time is. And the research and development projects, just like we have launching of satellite, these kind of projects we work with the PERT. And if we see why we PERT use it in daily life, it's used when activity times are uncertain. That is the basic funda here. Okay. So use PERT, managers use PERT, okay, for the projects like hospital planning, for such issues such as cost and social security, educational planning and development, various accounting functions, real estate development, you want to build buildings and all, PERT and computer project scheduling software, where we want to schedule the softwares and using the PERT. As an example, for example, a company wants to build a production unit, or company wants to build a production unit, or company wants to launch a new product. This is a production unit, a factory unit, or it wants to launch a new product. And there are a lot of steps involved in both of these, and we don't know which step comes after which, right? We know that this step has to be done only after this. So we have to wait. This guy has to wait for this thing to happen. So we need some kind of schedule, um, uh, where we can estimate the completion time and how much delay, how much this guy has to wait for this, so as to we minimize that delay and all, and we minimize the cost. And for that we can use the PERT. Now if you see the difference between CPM and PERT before we go for the PERT, because this question may also be asked, it's working the deterministic time while this has a probabilistic time, because here we have a fixed time and here we have 3 times. We'll see it shortly. Okay. And if it is for repetitive non-complex projects with certain degree of time estimates, we already know the time estimate, it's not that complex and it has already been done, this is a repetition of a previous project, then CPM is okay. It's used for non-repetitive, one time we have done, we are just doing it right now, it's kind of a research project or something, and it's a complex project, then, and time estimates are uncertain, we don't know exact times, then the PERT is going to be helpful. Okay. So in CPM we include time cost trade-off. In PERT is restricted to time variable only. Okay. And we use it for the construction purposes, and this is mostly used for R&D projects, where research and development projects, right? In the PERT we have 3 time estimates given. Okay. One is the optimistic time, maybe called TO, pessimistic time, I call it TP, most likely time, that is the time which is basically optimistic time is best time, the shortest possible time in which the activity can be uh, completed. And pessimistic time is a worst case scenario where you will say the longest time possible taken for the activity. And then there is a most likely time, which is a kind of a real time or average case kind of a thing, which has a highest probability of this time will be there to complete the activity, some kind of an average activity. Okay. Using these 3 times we calculate what is called as the expected time. This is our expected time. Okay. Which we calculate on the basis of 3, so such that which is again kind of an average kind of a time, which is most likely to happen and which is kind of in between of all of these, so where which is highly likely to be the time taken by an activity. So that is done by whatever the optimistic time is plus 4 times whatever the pessimistic time is, the worst case, the best case, the worst case, plus the most likely time divided by 6. By this formula we calculate TE, that is the expected time. So if we look again with the 3 times the optimistic time, which is the minimum time required to complete an activity, pessimistic largest time, and most likely, or we call it normal time. Okay. The best estimate, this is the best estimate we can to require the accomplished activity, but out of these we calculate the expected time. Okay. This is again the best estimate time required to accomplish an activity or a path. Okay. And this is on a fact that things do not always proceed the normal. The implication being the expected time is the average time the tasks were required if the tasks were repeated, if they are repeated on a number of occasions or an extended period of time. So what is the mix up of and the best possible time we can have is the expected time. Then we have to calculate the critical path, that is the longest path. We have seen it in the CPM also, which is from the start node to the end node. What will be the best longest path possible? It determines the total calendar time required for the project. Okay. Then we will calculate the float or slack, which is the excess time and resources available to complete a task, because it actually what I'm saying is it has a free float and total float, what we had done last time also. Okay. It will tell us how much we can delay a particular activity without delaying the project. Okay. Then there is a critical activity which are on the critical path, okay, whose float is equal to 0. If the float is 0, we can take those activities and they will determine my critical path, and the activities which lie on that critical path will be critical activity. And there is also the lead time, which tells us in what time the predecessor activity must complete before we can, jumpstart our the next activity. Now the formulas for standard deviation is TP, pessimistic time, minus optimistic time divided by 6, and the variance, which tells us variance actually how much your, if there is some median, and how much it is going far away from that, how the values are going far away from that. That actually gives the variance, which is the standard deviation which we calculated here, that is TP minus TO divided by 6, and you have to do raised power 2 to it to get the variance. Okay, then standard deviation is also, we can understand it like it is the days above average. How many days above average? You have calculated the days of completion. Uh, how many days you are going to complete the project, and what are the days above average in your project? Okay, that will give the standard deviation. Okay, then variance will give you how far a set of numbers are spread out from their mean. So if you have a mean value, you have calculated mean value, and how far the values go. For example, I say like this, if you understand variance, I will say the marks obtained is like 15 is my mean, that 15 is my mean. But someone has obtained 3 marks only, someone has obtained 20 marks, someone has obtained 4, someone has obtained say 17, someone has obtained 10, someone has obtained 16. So how far from the mean you are deviated? Okay, the marks are deviated or spread uh, about the mean, that is the variance. And then Z gives the days needed. This is what we need, days needed, how many days we are needed. Okay, that is the schedule date or due date, जो कि आपने डेट दिया है प्रोजेक्ट का कि भाई ये खत्म होगा. This is our date, which is the date where the project should finish. This is the due date. Minus, we will do it the duration. What are the duration we have? That is the expected date. Whatever the expected date is, this is the due date and this is the expected date. You minus them together and then divide by standard deviation, this thing. Okay, uh, then divide by standard deviation. Okay, so this will give us the this will give us the days required to complete the project. Now say for example we have given a question like this where there are the activities. This much is given, rest you calculate. Okay, this much is given to you and rest you calculate. Okay, so this is the 3 times we are given. Okay, one is the optimistic time and most likely time and pessimistic time. So 3 times we have. So this is activity 1 to 2, and we have the optimistic time of 2 and most likely time of 5 and pessimistic time of 8. So if we want to calculate the expected time, because we have to calculate the expected time, the first thing we do is to calculate the expected time. And how we do that is we do the what is the optimistic time, that is here for first is a 2, then we will plus 4 times the pessimistic time. Pessimistic time is 8. Okay, then we plus with it the most likely time, that is 5, and divided by 6. Okay, here's a little wrong, we have to 4 into the most likely time, that is 5, plus pessimistic time. Optimistic time is here, pessimistic time is here, and the most likely time is here. Okay, 4 times you multiply the this thing. So 5 into 4 is 20, 20 plus 28 plus 2 30, 30 by 6, that is going to be 5. So we get the 5 here. Okay, same way you can calculate all. So what you have to do is 4 into this will be 4 plus 4 into 9 plus 20. Okay, so this will be 4 into 9 36 plus 4 is 40 plus 20 is 60. 60 divided by 6, that's going to be 10. Okay, similarly calculate all of these. Okay, where you have to only plus 4 and this and plus these guys. So plus 4 into 11 plus 20 and so on. So we calculate the values, they are here. Okay, all of these will get it. Like for example, this 2 plus, we have 4 into 4 plus 6. So 4 is 16. 16 plus 6 is 22, plus 2 is 24. So 24 divided by 6, that's gonna be 4. Okay. Now if you want to calculate the standard deviation, that is TP minus TO divided by 6, that is TP minus TO, that is like this, 8 minus 2 divided by 6. So that is going to be 1. Okay. So standard deviation is TP minus TO divided by 6. Just calculate it. Like TP is 8 and TO is 2. 8 minus 2 divided by 6. That's 6 by 6, that is 1. Same way you calculate all others for the variance. Okay, TP minus T0 divided by 6. Then we have the variance, and variance I told you already that it is standard deviation. Then whatever the standard deviation is, raise power 2. Okay, whatever the standard deviation is, raise power 2 to that to get the answer of the variance. Whatever the standard deviation comes up here, okay, the standard deviation which comes here, you have to raise power 2 to get the variance. Now we need to calculate the critical path. Okay, for that we need to see what is my slack, and for that we need to see the earliest start time and earliest, what we have done in the CPM, the same way. In the CPM example, we have seen that there is the predecessor given, but here in this example, we can have that example here also where the predecessor is given, but that predecessor or precedence activity for the activity is here. We know we can go from 1 to 2, 2 to 3. From 2 we have to go, if this is 1, we can go to 2, for example. From 2 we can go to 3, we can go to 4, and we can go to 5. Okay, that is what this depicts here. From 3 we can go to 6, so from 3 we can go to 6. Okay, and from 4 we can go to 5 as well as 6. From 4 you can go to 5 and as well as 6. Okay, from 5 you can go to 7, so you can go to 7, and from 6 you can go to 7 as well, and from 7 you can go to 8. Okay, then we have calculated the expected time, which is with the everyone 1 to 2, that is 5 expected time. Okay, then with the 2 to 3 there is 10 expected time, and so on. So we can see it here in this diagram. So this is the 1, this is 2. Okay, so these are my activities. Like I can go from 1 to 2, 2 to 3. Now 3 can go to 2 can go to 4 as well as 5, then 4 goes to 5, and so on. Then there is a cost 5, 10, 8. This is the expected time which we calculated. Okay, all this 10, 8, 8, 12, 10, 6, 4, and 4. Then you can calculate also the total time. 0 plus 5 is 5, 5 plus 10 is 15. Okay, 15 plus 8 is 23, and so on. You can make a diagram. Now we need to find the critical path. So what shall we do? That's the same what we have done in our CPM. To find a critical path, we need to know which activity has a slack, or we also call it as a float of 0. Okay, and we know the slack or float can be calculated either by the we have the latest start date minus early start date or you could do it using latest finish date minus early finish date, because we have 4 times. I told you last time we have the early start date or early finish date, right? And similarly we have the late start date and late finish date. So you can calculate either way. Okay, either you can have the late start date and you minus it with the early start date, or you can have a late finish date and you can minus it with the early finish date. So at least you need to calculate either these two, or you need to calculate either these two. That is your choice. Whatever you calculate, then minus them together, and if it is 0, we take that activity only. Okay, actually there was an issue with the recording, so I don't know how much is recorded, how much not. I have to restart this thing. Um, okay, so we said we need to find a critical path. For that, we need to see which activity has a slack of 0. So to find a slack, we need to find the estimated, sorry, the early start time and early finish time, and late start time and late finish time. So these guys we find in a forward pass, and these two guys we find in a backward pass, right? So let us try to uh, actually I did it, but it didn't record. I should press the pause button, I guess, and I had to redo it. So we have the 4 boxes on the top of every node, right? So 4 boxes on the top of every node. I will try to do it a little quickly now. Actually, backward pass is recorded, the forward pass is not recorded. So I'm doing redoing the forward pass. Then I will join this piece of vid with the vid we having the backward pass. Okay, so we know if it is going to be the uh, early start, means when this is gonna start, okay, and early finish is the early start plus the computation time, that is gonna be my early finish, right? And early start we have to see sometimes if particular node has come from two nodes, like 5 is come from 2 and 4, we have to see who is the maximum, because 5 can start only when 2 and 4 finishes. So I have to see, because if you see 2 finishes at 5, 4 finishes at 13, so definitely 5 has to wait for 13 units of time. It cannot just start at 5, because it has to wait for 4 also. Yes, 2 has finished at 5, but 4 is still to finish at 5. It will finish at 13 unit of time. So 5 has no choice but to wait for 13 unit of time. So whatever is the maximum of the two, it will choose that. So with that, I know this is the beginning, so its initial early start and early finish is gonna be both zeros. Then I move to this, because it will start at 0 and it finishes at 0 plus 5 5. It is only a single node, so I don't have to worry about it. The 2 finishes at 5, so 3 starts at 5, and 5 plus 10, that is 15, it finishes, and so on. So 6, it has to start at 15, and 15 plus 8, that is 23. Now 7 has come from two ways, okay, so I need to calculate these guys also first. I have calculated 2, let me calculate the 4. The 4 has only single node, that is 2, so 2 finishes at 5, so it starts at 5 and ends at 5 plus 8, that is 13, right? Now 5 has come from two ways, either this way or that way. We have to see which one is the minimum, because 5 will complete only when the 2 and 4 finishes. So we have to see whose finish time is smaller, I mean greater. If the 2 has a finish time 5, 4 has a finish time 13, so I have to take this as my starting time, the greater one of the two. Okay, and what will be the finish time, because it has a 0 cost, so it will be 13 plus 0, that is only 13. Now when I go to the 7, I will calculate 6, I have calculated. Now when I go to the 7, 7 is come from the two nodes, either 5 or 6. So whosoever has the greater time, finish time, early finish time, because this is the early finish, this is the early start, this is the early start, this is the early finish. So which one is the early finish? Is 23 for 6, for 5 it is 13. So which one is greater? So 6. So for 7 has to wait till 6 finishes at 23, that will be its start point. Okay, and 27 plus it is 23, sorry, yeah, 23 plus 4 is 27, that is going to be it's this, and 8 has to start at 27, and the 7 finishes, that is 7 finishes at 27, so that is my early start of 8, and 27 plus 4, that is going to be 31, right? Now I have calculated the early start and early finish in a forward pass. Now we have to calculate the late start and late finish using the backward pass. So we start from 8, the project completion time is 31, that will be it, and 31 minus 4, that's going to be 27, that's going to be its early finish. Okay, this is early finish, early start, that's going to be early start. The early start of it will be the early finish of the next node. So if it is 27, this is also going to be 27, right? So how we'll calculate this one? This will be 27 minus whatever the computation time is. Okay, 27 minus 4, that is 23. The rest you can rest of the video is actually recorded. So I will join this with that vid. Okay, this is the latest start time of it. That's 27. This is going to be latest finish time of this node. Minus 4, that is going to be 23. And then if we go further to this node, this is 6 node. Its latest finish time is 23, and minus 8, that's going to be 15. And move forward then to this 3, it's 15, so it's going to be 15. 15 minus 10 is gonna be the 5. Then go forward, this will be 5. 5 minus 5 is 0. Then go forward, this is gonna be 0, and 0 minus 0 is 0. So I completed this way. Then I can need to complete this way also. Then go to 5. Now 5, it's 23. 23 minus if you say 0, that is going to be 23 only. Then go here, this is 23, and 23 minus 8, okay, that's gonna be 15, I guess so. And when I'm done, I got a 2, basically 2. Basically 2, I cannot calculate like this. I have to first see all the 3 options. From all the 3 options, which has the minimum the latest start time, so that is the 5. That is why I have chosen the 5. Otherwise, if these were the minimum, I have to take from these. Okay, so for 2 we have a contention. We have to see out of the 3 which is the minimum. So that is this one is minimum, so I have taken the 5, and then 0, and so on. So in this way I calculated it. If you don't understand, just go for the previous video where I have given the proper explanation of all these things. Now from this I have to do the slack. I have to use the slack or float. Okay, if I choose a different color, maybe now, maybe red. Okay, so the slack will give us what is this? This is the late start and late finish. Okay, this is my late finish and this is my late start, right? So if I divide the two, if I divide this and this, okay, if I divide late start divided by late early start, late start divided by early start, and I will see what's the value for this. For example, here this minus this divided by this is 0. Okay, and this divided by this is again 0. This divided by this is again 0 coming up. Whatever 15 divided by 15, that is actually I don't have to divide, sorry, it is to be minus. That is late start minus early start, or it could also be late finish minus early finish, whatever the two you like to do. Okay, so subtract 0 minus 0, 0 minus 0, 5 minus 5 is 0, 15 minus 15 is 0. Okay, here 23 minus 23 is 0. So for this is the slack, I'm calculating the slack or float. That is 0. For this, slack is 0. For this also slack is 0. For this also 27 by 27, or 27 minus 27, or 31 minus 31. You can do that way also. So for this also 0. So I'm having here 0, here 0, here it is 0, and here it is 0. And this case 50 minus 5 is 10. So it is not 0. For this guy is 23 minus 13, that is again not 0. So this guy is 0 minus 0 is 0, or 5 minus 5 is 0. That is late finish minus early finish. That is also coming 0. So here it is 0 slack, 0 slack, 0 slack, 0 slack, 0 0. So what will be critical path? Critical path will be 1 to 2 to 3 to 6 to 7 and 8. So this is gonna be my critical path. Okay, right? So let's clear now this thing. Let's go to the next slide. So critical path is going to be 1 2 3 6 7 8. Variance calculated in standard deviation, we calculated that, and expected mean time of the project is 31 days. Now if you see here, this was the standard deviation formula, so variance, and this is the days calculated, that is scheduled duration minus duration divided by standard deviation, that we see here, that is 35 minus 31 divided by 3.97. which is the standard deviation. That's calculated to be 1.07. Just do the maths. Okay, so the benefits of PERT: you will get the expected project completion time, probability of completing before a specified date. It facilitates critical path, identification of critical path, start date, end date, slack time for each activity. You can maneuver large data using the PERT, but there are some limitations. You have to clearly define the project activities which are independent and stable in the relationships. The precedence relationship must be specified because we need to know which node comes after which node and so on, and then they have to be networked together in a network diagram. The time estimates tend to be subjective and are subject to fudging by managers. That is the limitation of it. Okay, so to have some more emphasis on the critical path or the longest path, that's also gonna be its limitations. It's not easily scalable for smaller projects. That means it's good for the larger projects, but if we want to apply same on a smaller projects, it's not scalable. That means it's not applicable uh, easily for the smaller projects. And the network chart, it gets up larger and requires lots of pages if the project is complex. So that's also kind of a limitation to it. This is another worked example here. You can just go through this example. Okay, pause the video and just see it. Okay, then these are the this is the task, this is the least time, then the greatest time and most likely time. So you can, I'm showing you this because there are different terminologies, like we say optimum time and most likely time and pessimistic time. So that is your, the least time will be the pessimistic time, then optimistic time, the greatest time, and the most likely time. Okay, then you have to find the earliest and the latest expected time to each event, and then thereby the critical path. So this is your optimistic time or least time, greatest time, or pessimistic time and most likely time. Then you use the formula to calculate the expected time. This is the formula. We already have done it. You can pause the video and just try to calculate yourself these values. Then this is its earliest start and latest start and earliest finish and latest finish. Then calculating the slack, so seeing where the slack is, or total float or total slack is 0, that will constitute my critical path. Okay, and I'm just seeing where it comes to be 0, that's going to be my this. Then we can use a network diagram to see it, what is the earlier time and what is the latest finishing time and so on and so forth. From the table we just finish it. From here we can use the critical path, and yes, critical path has to be shown with double arrows, or using the, which I have not shown in the above example, which I should have shown, that A to C double arrow, then 2 to 3, 3 to 5, 5 to 7, and 7 to 8. Okay, so using the double arrows or the bold, you have to bold the arrow itself. Another example which has the following characteristics. Okay, with the, because we need 3 times here, optimistic, pessimistic, and most likely, and so on. Then these are this. Then you have to construct a PERT network, then find the critical path variance for each events. So this time around is also saying variance, and we know this is b minus a divided by 6 raised power 2. Okay, we have discussed this formula. You can just see, pause the video, try to do it yourself, and simply finish it. This is the diagram of it, and this is going to be a critical path. Okay, there's one more example here on this PDF. Calculate the variance and the expected time for each activity. You have to only calculate the expected time only. So they have the 3 times, you calculate the expected time and variance. Okay, pause the video and just check it out. We don't have to calculate the critical path and all, so we don't need the slack and everything. We just need the expected time and the variance. Now, example 4 is the project represented by the network as shown below and has the following data. So data is given, that is this guy, least time is this one, and greatest time is this, most likely time is this. So what you have to do is expected task time and their variance, earliest and latest time. So you have to calculate the expected time using this formula and variance. We have discussed the formula of it. Okay, then what is the earliest time? So just check it out. Earliest time is like this. You just use your copy and pen, try to calculate yourself, pause the video and check your answers, right? We have discussed this. So that's all for today, and with that our optimization syllabus comes to end, and hopefully you will do better in the exam. Go for revisions, do proper revisions and little bit of hard work now in revising from unit 1 onwards, and hopefully you will get a better marks in exam, inshallah. Okay then, best of luck and see you next time. Until then, ma salama.